Creation and simulation of a capacitance multiplier circuit with TINACloud. In this tutorial video, we will present how to create and simulate a capacitance multiplier circuit using TINACloud. Here is the original circuit we want to recreate for demonstrating the use of TINACloud's schematic editor. A capacitance multiplier circuit can increase the effective value of a small capacitor C1 to a much larger value. The capacitance seen at Vout is Cout equals C1 times R1 over R3. Note that this circuit is only for a ground-referenced capacitor. The output capacitance can be verified by placing an AC source in series with a resistor tied to Vout and running an AC frequency response analysis. We will show later on that the circuit behaves as if the C1 capacitor were multiplied by 1000 in the R1C1 low-pass circuit. Let's see how to create such a circuit using the SPICE model of the OPA725 Operational Amplifier. Click the SPICE Macros tab on the Component toolbar. The toolbar of the SPICE Macro components appears. Click the Operational Amplifiers icon. Click the little arrow in the Operational Amplifiers display window. The list of the available operational amplifiers from different manufacturers appears. Select Texas Instruments. You can now select the op-amp OPA725 from the list, or enter the part number into the top left search field of the dialog. Select OPA725, then press OK. The selected IC will appear attached to your cursor and place it anywhere on the workspace. Click the capacitor icon on the component toolbar. The schematic symbol of the capacitor will appear attached to the cursor. Position the symbol using the mouse, then left-click to place it. The capacitor should be rotated by 90 degrees. Rotate it by clicking the Rotate Left or Rotate Right symbol. Next, place the resistors R1, R2, R3, R4. Add the voltage generator and the power supply. Finally, select and place the voltage pin from the meters toolbar. So far, the components were inserted using their default values. Double-click the capacitor, and the Properties dialog box appears. Enter the required value, 100p, that is 100 picofarads, and press OK. Repeat this procedure for all components where needed. Double-click the resistors R1, R2, R4, and set their value to 1 meg. Then set the power supply's voltage to 10 volts. You still need to add a few more components. Go back to the basic toolbar and add 4 grounds to the circuit. Note, you can rotate parts even before you place them by clicking the Rotate Left or Rotate Right symbol. Now you can wire up the circuit. Note that TINACloud has an advanced wiring tool that automatically inserts the components into the wire. Now your circuit is ready. Save it, then test it. Save your circuit, e.g. under the name Capacitance Multiplier 1. Note that the program automatically saves the changes into this file while we are editing. To start the simulation, select Analysis, AC Analysis, AC Transfer Characteristic, then click the Run button in the Analysis display window. Let's find the -3 dB cutoff frequency of this circuit. Invoke the cursor on the diagram window by clicking on the red A icon. The cursor A will appear. enter -3 into the data field of the cursor at the bottom of the window, then press the Set button. The cursor will jump to the -3 dB point. You can, of course, also position the cursor by clicking and dragging the A symbol on the screen. The -3 dB cutoff frequency is 1.6 Hz. The cutoff frequency of the R1C1 low-pass circuit, without the op-amp, can be calculated as FC equals 1 over R1 times C1 times 2 times pi equals 1591.5 Hz. FC is approximately 1,000 times higher than the 1.6 Hz cutoff frequency of our circuit. Indeed, the circuit behaves as if the C1 capacitor value were multiplied by 1,000. Let's add this diagram and a title to the schematic design using the schematic editor. Select Insert Diagram from the Insert menu with a green plus sign, and then AC Ampli 1 from the list to include the amplitude diagram. You can also resize the diagram if you wish. Click the Insert button. The diagram will appear attached to your cursor. Position it, and then you can add it to the circuit diagram by pressing the left button of the mouse. You can move and place the circuit wherever you wish on the workspace by using the Multiple Select button. Press the Multiple Select icon. Using the mouse, now you can select components. Use window selection. Drag the circuit by clicking a component and holding down the left mouse button. The circuit will be attached to your cursor. Position it by moving the mouse and holding down the left mouse button. Then, release the Multiple Select icon and click an empty spot on a workspace to deselect the components. Add the title by using the Insert Text T icon. Edit text properties by clicking the Properties button. When you finish editing, press OK. The circuit with the embedded diagram appears. For more information, visit our website at TINACloud.com. Visit our YouTube channel to youtube.com/user/TINA Design Suite.